Hello everyone. So this is lesson 14, include about the multicast and the mobile IP. Actually, this is on the video to record again to help you maybe can go through the final exam is easier. In this video, I record some part for the firewall configuration and the second part I will go more detail, provide more detail about the global internet, multicast, and the mobile IPs model. About the first thing, I already introduced by the firewall, right? So that's kind of the software or the hardware try to protect the internal of the network and kind to provide kind of some function to filter the packet, to allow which packet can pass, which packet can be dropped or blocked. Yeah. So in the firewall, we have many configuration. We can use an IP table and filter the traffic. Like you can place between the web server and protected the intranet, and we can place a firewall between the web and protected the intranet and the base station. That's kind of the external the protection server, and we can place to the firewall, the one before the protect internet, and the other we can create as a public web server and one the base for monitoring the traffic. So that's like about the create about the firewall, the root implementation. So we have a stateful and stateful, right? And in this example, uh, I suggest I introduce about the the state list. So over here we have two requirements. We allow DNS service and we block all the other traffic except from the IP. This one IP, yeah, this from this IP, and use the web service. Okay, we can analyze the requirement. Allow DNS. So allow DNS, so we can allow. We do not specify any source and IP, so we can set star. Yes, star. That means any. This can say any star. Yes, star. And DNS that's kind of UDP protocol. So we can set protocol and source port. We don't need to care, but we only specify by destination port. That is a DNS service, right? So this is the first rule, allow DNS service, and the second rule, we block all the other traffic except with destination IP and use the web service. So over here you need to analyze a request with destination IP, so we can put the destination over here, right? We allow first or deny later. Allow okay destination and web service. The AT, the port is HTTP, right? HTTP. And we source port we do not care, and because the web service is UTCP, so remember this one. And we only need to care about the destination IP, so the source IP we do not take care, so can be any. And after this one, we can block all the other traffic. We can place deny all or star. Yeah, you can make star over here, star or star. Yeah. And if you see, we cannot do this kind of practical. We can give live. We can block all the web asset a DNS from this IP. This IP, this one from block holds the web asset and DNS service from the PC, this one, the CCO network, but allow the PC, this one from the internal, right? External from the outside, can remote step to the desktop to the any PC to the CCU. So this are the requirement. Yeah, you need to. And remember in our lab we already do this part. So please refer the solution over there. And the second part you can do live again given follow the network, and we can configure specify three requirements. Allow the own FTTP the access from the outside. Yeah, on the outside. Yes, this one from outside, right? And but we block all the SSH requests from NTU. This from the NTU, right? To the CCU. So okay, we can analyze one by one. We block all. Okay, and block all. Okay. The third one, we allow the DNS query from the old network. Okay, over here we want create about the allow first or permit first, deny later. First is allow DNS request, right? So we can insert source for all the networks, right? So over here you can place this kind of the firewall route in this CCU, or you can apply it NTU. Yeah, you can apply it in the CCU first. So over here you can place a star this DNS, so UDP, right? So we do not care about source port, so we don't care about the destination port. That is the allow DNS request from the owner network. So now we can block all the FTP access from the outside. So that means inside we still can allow, right? So we can allow this one. This from the inside, because our CCU have a network address, this one, right? So we after this one we can insert the deny any own, because it's own, right? Own. So we can add star, and with destination, this one we can deny or block all the HTTP secret from the outside. With destination, that means we spec a source is outside, right? With TCP, and is the port is about the ATP. Do similar deny for you can apply this star. No this star, because this star something they conflict with this one. So you can specific or outside come from the this one from the NTU, so you can specific for SSH, right? So because this one is a requirement from NTU, right? So you can specific IP for NTU over here, NTU, yeah, NTU, and after you can have a default the root deny all. Okay, so this is an example to create about the firewall, the root for specifying three the requirement. And in you can access this kind of route in practice. Like if you have a router, Wi-Fi router, you can access that in the the security rule. Like you can set a UI or a filter. You can set about the firewall. Yes, firewall, the route. Yeah, you can create about the inbound the firewall rule over here. Like you can specify name, local port, something like that. Yeah, you can see over here, you can support enable. You can access the source interface, so address. Interface is the port, okay, the port destination address. You can check IPv4 or IPv6 actions and deny or permit. Yeah. So this one can support in this is gigabit VPN router. This VPN router. And in firewall I pivot table, so you can create this kind of role, so you can check it. Yeah, you can check it. In commercial, it's like a PF send. So creates the firewall rule more visual. So you can see you can create protocol, source, port, destination, port, gateway, queue. Yeah. Actually, like you can allow a ping. You allow a ping, right? Ping. Yeah. Okay, that is a remind how you can create about the rules for the firewall. And this is part for the last one. I will introduce you about the global internet, multicast, and the mobile IP. Yeah, mobile IP. Okay, here is the global internet in a glance. So you will see over here we have several key points. First is most country over the world still do not have any node in the network. Yeah, right. So you see in this part, mostly in Africa. Yeah, in some countries in the in the West Asia. Yeah, or in South America, South America. And most computer network we focus concentrate in in Europe and in United States or in Japan, Korea, in China, in Thailand, yeah, in Taiwan, yeah. And you see this kind of the fiber under the sea, under the sea, between the connection between the Europe and the the United States. Yeah, very dense. Yeah, very dense. And about the next generation network, we when we have a connection between the satellite, we will connect to the air ground or the marine. Yes, it's marine. UAV can connect to the ship. Yeah, the ship, and can connect to the area remote area or connect to the vehicle, smartphone, smart city. Yeah. So that's called NGN, the next generation network. They can kind of integrate many communication technology together. So currently 3GPP, yeah, uh, 3GP they have the other same kind of the term is called NTN, yeah. Next generation. And when we have a lot of the provider or ISP from the Chunghwa Telecom or Taiwan uh, Mobile, and we have Chunghwa Telecom, right? And each of these kind of ISP will connect together. So each one will be, go to how the, core network. And we have interdomain the routing and use BGP. Yeah, we already talked about this problem when we learn about the routing. So BGP can provide the connection between the two different autonomous system. Like this is autonomous system run the RIP protocol, right? And this one runs about AEGIP, yeah. And this one maybe runs the OSPF, yeah, OSPF. So the BGP can support this kind of connection. So we have the border this kind of BGP router, yeah, BGP router will be connected the different autonomous system together, yeah. And when the route population so go to the many area, so they can provide a kind of hierarchical the algorithm to provide create a larger internet. Okay, this one I think you can check in slide. And IPv6, you already know that, right? So IPv6 include about 128 bits address, and they can support many features like auto configuration, support end-to-end fragmentation, and IPv6 you can see spatial the format. You can see, yeah, include about hexadecimal. The value is different from the IPv4 the address. Okay, IPv4 we can have line 192 something like this, right? So only include the digits, but in the IPv6 include about the number and about hexa the number. Yeah, hexa the number. But in IPv6 it can cover so many devices. Actually, every device in over the world they can support one IPv6. Yeah. Okay, IPv6 header. This one is about the multicast. The last, the multicast. Actually, the currently I think have one of the two most important communication models. That is one-to-one. Yeah, one-to-one. Okay, one-to-one. That means the one PC. Yeah, they can communicate with one PC. This is common. All the other common, that's broadcast. On a server can share the share service for many PC, right? So one to many. That is a called broadcast. So actually, this kind of broadcast, the more famous in the streaming, yeah. But actually, in computer networks, we still have the other model, but it's a seldom to use. It's called many to many, or the multicast. Multicast is a kind of the special case for the broadcast. Okay, broadcast, for example, this is model on the PC, broadcast for every PC, right? So in multicast, we only select these two PC. We only select one group, one group in broadcast, to make sure this kind of group can get a message, the other cannot, So this kind of multicast, you see, we have a tree model. We have a unicast. That means unicast can send only on each PC. Broadcast we send for every PC, right? But the multicast we only select these three to PC, and each one need to subscribe. Okay, sorry, I tried a little bit early. Yeah. Or we need to have a spatial address. Actually, spatial address we will class D and E. Yeah, we have multicast, so you can check. Okay, this one we can skip because I want to give an example. With multicast, well, we need to send the message one by one, or we need to send to all, right? So with even one multicast, I need to select one group. Yeah, so it's more suitable for selected multicast. You can apply many to many, and each device in this multicast need to have a spatial address. Over here we have a class D. Use multicast. If the one of device want to join any kind of multicast group, it can assign this kind of address. Yeah, it can assign or subscribe. Just subscribe to this kind of address. Over here, I have a several the famous, some the most famous multicast address. Now this one have for all the multicast device or router, or this one for some specific router, or this one for video or audio application. So to support a kind of join or leave the one group multicast group, we have two mechanisms. In IPv4, we have internet group management protocol to support join or leave multicast group. In IPv6, we have a multicast listener discovery or MLD can support to decide you can join or leave to the multicast. Yeah, this one for let you know. Okay, in the multicast routing, so based on the multicast address, so the router can specific classify the traffic, follow a kind of specific address, and only forward the data to that kind of specific destination address. Yeah, destination. Similar over here, we have if the router have the class D, the IP, like if the router have this one, right? This address. So that means every OSPF the router can receive that kind of message. The other cannot. Yeah. But how to confuse the multicast routing in packages that have CCNP the level and for professional or for experts. So I do not tell you over here. You interesting, maybe you can align this video. Maybe I can create some new video and help you understand how the multicast is very complicated. I can show you some simple example. Yeah. In the routing in multicast, we have a distance vector, and we have interdomain multicast, and we have a routing for mobile host. This one is you can check more in the slide. Okay, so because multicast is more complicated, and actually this one for advanced the network, advantage the network, the course. So I hope you only know the definition and know what's meaning and what how to join and how to leave the protocol for join and leave. So and I mean how they transfer the data when we have the normal the router and the multicast router. So that's all. Okay, this is in video we already covered about the firewall, right? How you can confuse the firewall and what is a global internet look, global internet structure look, and we know about the BGP, yeah, and try to interdomain the routing protocol, and we know about the multicast, maybe very useful in some specific application like streaming or gaming, but if multicast want to work on the internet, the multicast the router need to have a special address like a class D. Yeah, and if someone to join this kind of multicast, the group need to have a kind of special protocol like a MLD to join and to leave or subscribe that kind of group. Okay, so that's all. So I hope this one can help you to go through the final exam. Okay, so today is the last day for the new, last day for 2023. So I hope everyone will have a great new year. Okay, good luck for the final exam.